So see, this is the numerical where we have to determine the power lost in the circuit. We have to determine the power lost in the circuit using the which method? Using the mesh analysis. Okay, using the mesh analysis. But before applying the mesh analysis, we have to determine our loops. Okay, so first, and the second thing is that here see we have a one voltage source and the one current source, and whenever we have to apply the mesh analysis, what we have to apply? The KVL loops. So for KVL, the basic requirement or basic terms to make this numerical easy, we have to get the voltage sources. Okay, जब तक voltage sources ना हो तब तक it will not be easy to solve using a mesh analysis. Okay, ये first method होना चाहिए हमारा. So see here we have a 1 ampere source, 1 ampere source. So we have to convert that ampere source into an equivalent voltage source. Okay, but here the see, what is the requirement? If we have to convert this current source into an voltage source, we want a branch element parallelly connected to a current source. But is it here connected है क्या हमारे पास current source के parallel में, exactly parallel में कोई branches है क्या? नहीं है. Why? डायरेक्टली कनेक्टेड नहीं है, बीच में हमारा लूप आया है, यहाँ पर नोड प्रेजेंट है. So we can't consider directly it is. So we will use a concept that is a source, shifting. Okay, source shifting. See, this ampere source is connected across a 10 ohm and 10 ohm, but in between there is a node. We can shift using a shift node. What we do, we will shift a current source into a two parts connected to a this node. Okay, so here I'll get a two current source connected across a branch. Rest of the circuit is as it is it? 1 at an angle 0 degree, 1 at an angle 0 degree, ampere, 10 ohm, J3 ohm minus J5, and this voltage source as it is. Okay, now you have to convert this current source into its equivalent voltage source. Do it fast. For the equivalent voltage source, what is this? Here a voltage source connected to a branch in series, similar here, and here it will be a voltage source. This is your inductive impedance and this is capacitor. J3 minus J5, 10 at an angle 0 degree volt. Now for the conversion, 10 ohm as it is, 10 ohm as it is. What is the equation for current? Voltage into the resistance. Voltage upon resistance. Voltage into I into R. I is 1 at an angle 0 degree into the 10. That is nothing but 10 volt. So here we get a 10 volt and 10 volt. Direction is this side. So this is plus minus. Clear? So now this is a basic circuit. So apply the mesh analysis in loop 1, and in loop 2. Okay, so apply KVL in mesh 1. Tell me the equation. 10 at an angle 0 degree, plus or minus, we are going from this side, so it will be minus 10 into I1 minus J3. It is a common branch, so it will be dominating current minus second current equal to 0. Okay, keep the voltage source on the left hand side. So 10 at an angle 0 degree minus 10 is nothing but 0, equal to all these voltage drops on the right hand side, J3 I1 minus I2, 0 equal to 10 I1 plus J3 I1 minus J3 I2. Final equation is 0 equal to 10 plus J3 I1 minus J3 I2. This is your equation number. Now go for the second loop. Apply the KVL in mesh 2. Okay, what is the equation? Equation will be starting with the voltage source, minus 10 minus 10 I2 minus J5 I2 minus J3 I2 minus I1. Solve this. So now the voltage source on the left hand side equal to plus 10 I2 minus J5, plus J5, minus minus it would be plus, so here it will be minus J5 I2 plus 3 I2 minus I1. Equation is minus 10 equal to 10 I2 minus J5 I2 plus 3 I2 minus 3 I1. So minus 10 equals to 10 I2 plus 3, it is a J3, it is a J3. So 10 minus J5 plus J3 I2 minus 3 I1. So final equation 10 equal to minus 3 I1 plus 10 minus J2 I2. This is your equation number 2. Clear? It is a minus J3 minus J3 I1 plus 10 minus J2 I2. Arrange the equation number 1 and 2 in matrix form as Z I equal to V. Z, how many loops? I1, I2 equal to voltage. Tell me the equation. First, as per the equation number 2, one second, minus J3, this is 10 minus J2. What is here? 10 plus minus J3. Okay, this is the your matrix equation. Now in a question is what we have to determine the power lost in the circuit. So the formula for this is what? Summation of I square R, and here the R is what? We have 2R plus 10 and the 10. So equation will be, here the current flowing through this 10 ohm is I1 and the current flowing through this 10 ohm is I2. So equation will be I1, magnitude of I1 square into R plus magnitude of I2 square into R. Give this is equation number 1. This is equation number 2. That means what we have to determine the I1 and I2. And according to the Cramer's rule, we know the equation of I1 del 1 by del and the I2 is del 2 by del. So we will go with this formulas. Okay, so keep it here. First we will determine the del, and we know the del is nothing but what? The matrix Z. So solve this. 10 plus J3 minus J3 minus J3, 10 minus J2. Solve this and tell me the answer. Simply put in calci 10 minus J2 minus of minus J3 minus J3. 115 plus J10, and in polar form 1 second 115.43 at an angle 4.9697. This is the answer of your del. Now go for the del 1, and the rule for del 1 is that we have to replace the column 1 by the column of voltage source. So the del 1 equal to 0 minus 10 minus J3, 10 minus J2. Answer 30 at an angle minus 90 degree. Okay. Similarly for the del 2, in case of del 2, we have to replace the column 2 by the voltage source. So 10 plus J3 minus J3, 0 minus 10. Answer 104.30 at an angle 163.30. Okay, now we get all the values. Now put in equation number of I1 and I2. Put the values. I1 is equal to del 1 by del and I2 equal to del 2 by del. Answer. First one, I1 0.2589 96 4 digit 0.9044 at an angle 269 ampere. Okay, now according to the equation number 2, from equation number 2, power lost equal to I1 square into 10 plus I2 square into 10. now put the values. सिर्फ मैग्नीट्यूड लेना है तो 0.2598 स्क्वायर इंटू 10 प्लस मैग्नीट्यूड 0.9044 स्क्वायर इंटू 10. फाइनल आंसर 8.8543. that is a watt. So this is your final answer. Clear everyone?